Alright, chemistry, we're continuing on with the answers video. I'm going to do some selected problems from the day 1819. Okay, so we're going to do one now, one of the simpler ones. And this is on number 8, it's how many moles CO2 are produced from 5.3 moles of C3H8. So this is a hydrocarbon called propane. Okay, so moles of CO2 is what we're trying to get to. And that's right here. And we're starting with 5.3 moles of C3H8, so we put that here. And that's just a simple single conversion, going from here to here. So you get the equivalency out of the chemical equation. 1 mole C3H8 equals 3 moles of CO2. So let's set up the equation and do that. Okay, there we go. So it's one arrow, one conversion. We start at 5.3, we end up at the number of moles of CO2, and there's our equivalency straight out of the chemical equation. Alright, so which one goes on the bottom? Well, it has to be moles of C3H8. Okay, so we canceled moles C3H8. Last man standing is moles of CO2, and it's 5.3 times 3 is 15.9. Okay, now we're going to move on to letter C, that same problem. And it's how many moles H2O are produced from 4.83 grams of O2. So let's go ahead and start setting up the equation before we even look at the flow chart. So we're trying to get the sum number of moles of H2O. Alright, and so we see that we're starting with 4.83. We're going to end up with moles of H2O, 4.83 grams. So we come up here. Alright, and it's moles of H2O. Okay, so we're trying to get the moles of H2O. That's what we're trying to find. That's right here. It's in the moles row under H2O and 4.83 grams of O2. So we go down to the grams row and we come down under O2 right here. Alright, and we need to go up into the moles row and then across over there. So that's 2 arrows, 2 conversions. Alright, so that's what our equation is going to look like. So, at first we have to go up. We can change that to a 32. Okay, that was an error that was corrected earlier in class. So you have to go from 4.83 up to moles of O2. You have to go through the molar mass of O2. Okay, so we needed grams on, we had grams on the top, we needed grams on the bottom, this one. So we're going to cancel those. Now we're sitting in the moles of O2 box, that's right here. So now we need to move across to moles of H2O for our final answer. And again, you get that right out of the equation. 5 moles of O2 equals 4 moles of H2O. Cancel moles of O2. Last man standing is moles of H2O, which is what we want. So now 4.83 times 1 times 4 divided by 32 divided by 5. Okay, and we get 0.1207, and we can have 3 significant figures there. So that's going to be 0.121 to 3 significant figures. That's your answer. All right. Now we're going to move down and do another grams to grams down here. So we'll go ahead, skip down to E. How many grams of O2 are needed to produce 5.67 grams of CO2? So let's go ahead and start our equation. We're looking for grams of O2. Okay, so we're looking for grams of O2. So we go down to the grams row, come over underneath O2 and put a question mark. We're starting with 5.67 grams of CO2. So we come over here, grams row again, under CO2. Okay, go from what we know to what we don't know. You go up, go over, and you go down. Okay. Alright, and one thing you needed to do is fill these in. So they were already calculated down here, 44.01. and 18.02 for water. Okay, so We're first going to go from here up to here, to what's in between these two boxes, the molar mass of CO2. So let me go ahead and draw the 3 boxes first. Okay, we see grams of CO2. That means grams of CO2 has to go down here. Alright, and so grams of CO2 cancels and cancels. Okay, next we need to go from moles of CO2, that's where we are now, over to moles of O2. Simply set them equal to each other. 5 moles of O2 equals 3 moles of CO2. Okay, there we go. So now we're sitting in the box of moles of O2. We need to get out to here. That means we need to use the molar mass of O2. And grams of O2 is the last man standing. So now we're ready to do the calculation. Okay, and this says I can have 3 significant figures of 5.67, so the answer is 6.87. Okay, so I'll leave you to do the others on this page. Go ahead and do those, and I'm going to move on to the next problem. Okay, so this is we're moving on to a different type of reaction, a double replacement reaction. And in this problem, I asked you to compute the molar masses. So be sure you can do that. So I'm going to do that right here, right now. Okay, so that's the calculation of the molar masses. Okay, so we're going to do A down below. A couple corrections. These should be subscripts, KNO3. Okay, so it's a moles to moles. That's the easy one. So we're going to go ahead as we want to know how many moles of KNO3. And we're starting with 2.7 moles of K2CO3. Okay, we have to go up here, and we'll go ahead and put this in here, moles of KNO3. What we're trying to find, we're starting with moles of K2CO3. Okay, so it's a 1 conversion problem from 2.7 to the question mark. So that means we need 1 box. Okay. So this is one of the easy ones, so I worked out the steps. You're trying to end up with moles of KNO3. You start with 2.7 moles of K2CO3. Your equivalency comes from the equation between these two right here, the 2.7, the question mark. So it's 2 moles KNO3, 1 mole K2CO3. So that's your equivalency that you write down here. Okay, you have moles of K2CO3 here. That means you have to have moles of K2CO3 on the bottom here. So you're going to put that one on the bottom, put this one on the top, cancel. Last man standing is moles of KNO3. So it's 2.7 times 2 equals 5.4, and that's your final answer. Okay, next I'll do D. That's a grams to moles problem, so we're trying to find how many grams of KNO3. Again, these should all be subscripts, so that's a 3, and that's a subscript 3, okay? We want to know grams of KNO3. Alright, so we're going to put grams of KNO3 as our question mark. That's going to be down here. Okay, and moles of HNO3 is where we're starting. That's right up here, and it's 8.2 moles. So we move from here across and down. 2 arrows, 2 boxes. Okay. First equivalency from here to here is out of the equation. It's 2 moles KNO3 equals 2 moles HNO3. Okay, so that puts us in the moles of KNO3 box right here, and we need to get down here to our final answer, so we use the molar mass of KNO3. Okay, so we multiply everything on top, divide by everything on the bottom. Okay, and I get a calculator answer 829.102, but this says I can only have 2 significant figures, so I'm going to make that instead of 829, I'm going to round it up to 830, 0 and no decimal. So I only have 2 significant figures, the 8 and the 3. That's the answer there. Okay, we're going to do one more. Let's just go down to, let's go to the next one down, E. Okay, so how many grams of H2CO3, again, those should be subscripts, so grams of H2CO3, and we're going to start with 3.2 grams way over on the left of K2CO3. Okay, so we come over here and we're going to clean up our flow chart. Okay, grams of H2CO3 is down here, grams of H2CO3, and we're starting with grams of K2CO3, and it's 3.2. Okay, so we need to get from here to here. We have to go up, over, and down. Okay, 1, 2, 3 conversions, so 3 boxes. Okay, so here we are right here, 3.2. We need to get up here, so we need to, what's in between those two is the molar mass of K2CO3. Okay, grams on top, K2CO3, grams on bottom. So now we're sitting in the moles of K2CO3 box right here. We need to move over from here to here. So there's the equivalency. 1 mole H2CO3 equals 1 mole K2CO3. You need this to cancel out, so you got to put moles of K2CO3 on the bottom. Now we're sitting in the moles of H2CO3 box here. We need to come out to get the grams of H2CO3, so we use the molar mass of H2CO3. All right. Moles H2CO3, moles H2CO3 have to match up. The other one goes on the top. Moles H2CO3, moles cancel out. Grams H2CO3 is the last man standing. That's what we need there. Okay, so we're going to multiply 3.2 times 1 times 1 times 108 divided by 138.21 and see what we come out with. Okay, into 2 significant figures we come out with exactly 25. Okay. Alright, so you do the rest of these. I'd be happy to give you check answers so you know whether you did them right. But come in for tutoring if you need help with this.